What's up everyone, it's Bryce, and this is the second video in a three-part series on building generative UI applications with LangChain. If you haven't seen the first video already, you should go back and watch that. In that video we cover some high-level concepts such as what is generative UI, we cover use cases, and then also we go over the high-level architecture of how we're going to build this chatbot, and then also in the next video, which releases tomorrow, the Python chatbot, which will be a Python-powered backend and Next.js frontend. That being said, if you are not a TypeScript developer, you should probably hold out for tomorrow's video, or you can still watch today's video because some of the topics will overlap with the Next.js frontend and the AI SDK, which we will use to power some of the code which sends the UI component from the server, or in this video's case, the React server component, back to the UI. So as a quick refresher, this is the high-level architecture of what the chatbot we're going to be building today will look like on the inside. So it takes some inputs, user input, any images, some chat history, sends that to an LLM. The LLM has some tools bound to it. Then using that response, we have this conditional edge. If you're familiar with LangGraph, you should know what a conditional edge is. If not, I'm going to link a video going over LangGraph, which you should watch because that is what we're going to be using to build our LangGraph agent in this video. So the conditional edge says if there's only a plain text response, then stream those chunks back to the client. And then as those chunks come in from OpenAI or whatever model provider we use, we render them on the client. If a tool is used, that gets sent to our invoke tool section, where we first stream the initial component back to the UI, which could be some sort of loading component or UI element that tells the user, hey, we have processed your request, we're using this tool, and we're going to get back to you in a second. So it just allows for a quicker time to first interaction. We then can execute some arbitrary tool function, which is just a generic TypeScript, JavaScript function. So in our case, it'll typically be hitting an external API. And then once we get the response back from that, we update our UI component stream with the final component and close it. You can call update or append as many times as you would like to update or append UI components to the UI your user sees. The way we're able to stream all of these events back to the client is via the stream events endpoint in LangChain. Stream events essentially is a way to stream intermediate steps from your LangChain application back to the client or just send them in a response object. Since this is all using LangChain and LangGraph, stream events is able to access every single yield that a function might yield. So in our case, we're going to be yielding UI components, we're going to be yielding data, and then once again yielding UI components again, or yielding text. And stream events is able to just capture all of those streams and then forward them back to the client. Okay, so the first file we're going to want to implement is our utils/server.tsx. Oh, and if you want to follow along, the link to this GitHub repo will be linked in the description. You can clone it, and then you can go through and read each of the files as we code them. The code will all be there in that repo. But this first server.tsx file, this file is what's going to contain all of our logic around streaming UI components and invoking our runnable. So let's add our imports. The first line, you can see it's server only. All of the streaming UI components and invoking the runnable will happen inside of a React server component. So we want to make sure this file is only used on the server. Next, we're going to import React node and isValidElement from React. We're going to use this for typing, as this is a type, and then isValidElement we're going to use to make sure the elements inside of our stream from our runnable are UI elements before sending them back via the AI SDK, which leads us into this next import, the AI SDK imports. We use the AI SDK under the hood to handle streaming back UI components because they do a lot of the heavy lifting with React server components. Next, we have some imports from runnables, from LangChain core/runnables. This will be what we're going to be using as a type, and then also runnable lambda is what we're going to use to wrap one of our streaming UI components back, so we can essentially upsert the UI components into the stream event. Next, these are all going to be for types. We have our stream event type, and then we have our AI provider, which is going to provide context. We're going to use this to wrap our children so that all of the UI components have the proper context. And then this we're also going to use as a type. So the first function we're going to implement is the with_resolvers function. This function is going to return a promise and then a resolve and a reject function. We're going to use these so that when you are streaming back from the UI component, when you're streaming the UI component and any other values from our chain, we're able to properly resolve the final promise and know when our UI is done streaming. Inside of this component, we have a resolve, reject function, a new promise, which then assigns the resolve and the reject function to the resolve and reject functions from the promise, and then we return it. We need to expect the error here because TypeScript does not think that these have been assigned. Technically that's true, however, the way we're going to use this, we will always use this promise before calling these resolve and reject functions. So although TypeScript thinks they're not used yet, in practice we will use them after calling our promise. Next, we're going to implement our expose endpoints function. This function is what we're going to use to return the proper actions and provide context to these actions so they can call our agent, and then also so our UI components have the proper context. We're using this AI provider React context that we imported from client.tsx, which is in the same utils file if you're following along. And then as we see here, we also have this use context hook, which uses the use context from React and is going to provide context to our client-side files so they can properly invoke the agent. Here it's pretty simple. It returns a new function AI, which contains an AI provider React context or JSX component, which you saw in the other file. The next function we're going to want to implement is the one which will handle streaming back all of the UI components. So handling this stream, and then it's what passes the UI components from our tool call functions up into our stream events call. So we'll implement the stream events function after this one, but this function we're going to implement is essentially wrapping the AI SDK and a runnable lambda, and is streaming and yielding these UI components so that we can access them inside of our stream events. We'll implement that here. It's going to be called create runnable UI. Takes in two args. One is required, the second is optional. The config argument, this is going to be used to, we're going to pass in our config values here, and this is so the stream events, when we invoke stream events, it's going to have access to this runnable lambda function. Next, we take in an optional initial value. This gets passed to the create streamable UI function. So you see right down here, we have our runnable lambda. This lambda takes in a single input of an initial value, which should actually be optional. This initial value is going to get passed to the create streamable UI function from the AI SDK, and then we're going to return this UI value. This UI function is going to have a value, which is the JSX element. This is what we're going to use to actually send back to our client, and it's going to contain the stream, which can update anytime we call update, append, error, or done. And this is what we're going to render on the client. We then attach a config so that this runnable lambda always has the same name, stream UI lambda, and this is what we'll use later on to identify this runnable lambda and extract the UI value from it. And then we're going to return us invoking that function, passing in the proper config so that using we pass in the config so that stream events is able to find this runnable lambda inside the same stream event. The next function we're going to want to implement is the function which we'll use to invoke our agent. This is also going to call stream events and extract any UI values we return from here. So when we invoke our agent, it's going to be calling stream events inside of this function. So let's paste that in, and then let's walk through exactly what this does. So it's called stream runnable UI. The first line, we're creating a new streamable UI from the AI SDK, and then using that with resolvers function we implemented below. The last event, which is our promise, and then our resolve function. We then have an async function which executes in here. We have some callbacks which contain a string, and then either the return type of create streamable UI or create streamable value. We'll use those in a second. And then, as you can see, our first input is a runnable. We're going to call stream events on this runnable to stream back all the events. This runnable will be our agent. We iterate over each event, and the first thing we do is we check to see if it's a UI value which was returned from this lambda. So as we can see, our run name is here. We're checking to see if the stream event.name is that run name, and it's after that lambda has finished. So on chain end should be the event. If it is that event and runnable lambda, we're then going to check and make sure that the value of the output is a valid UI element. If it is, then we're going to append that UI element to our UI, which we created via the create streamable UI. Next, we're going to check to make sure that it's a stream and it's not a chain. This is what we're going to use to extract any text values from our agent or our LangGraph graph. That will be this part of our diagram where the LLM returns just text and we'll send it right back. So if it is text and type of chunk.text is string, we want to make sure we have not already processed this run event, because your LLM could in theory invoke a language model twice and get two sets of text streams back. So we make sure that we've not already processed it. If we haven't, then as this comment says, the create streamable value / use streamable value is preferred, as the stream events are updated immediately in the UI rather than being batched by React via create streamable UI. So if we're just updating text, we want to use this create streamable value and not create streamable UI. Then we're going to append our create streamable UI with a generic React or JSX function. This could be, this is customizable for what you want. We have the AI message text, which is going to be our text bubbles, but you should probably replace this with whatever UI you want. In here, you see we're using create streamable value, which we mentioned there. And then the value of that is the value of our text stream. And we're using text stream so we can bypass any sort of batching that React does and instantly update our UI with the stream as it comes in. Next, if the run ID is true, which it is because we just said it, we're going to append the text from the stream event chunk. This will be the text language model stream back. And then we're also going to be updating our last event value of the stream event. This happens at the end of each stream event, so we know that the last event value will always be the last stream event. Finally, when our stream events has resolved, we're going to resolve our promise, which we implemented in the with resolvers function, with the output of our stream event. This will typically be some sort of string, but it could also be an object with, say, our tool call. We're then going to iterate over all of our callbacks and call done on them to finish our callbacks, and then call UI.done, which is going to close the UI stream between the server and the client via the AI SDK. Finally, we're going to return these values and the last event, which we will use in our client when we implement that. Now that we've implemented our stream runnable UI and create runnable UI, we can go ahead and implement our graph. This is going to be this language model graph with the edge, invoking tools, or sending back the response. We're going to go into the AI/graph file, and first things first, we're going to add our imports. As you can see, we're not adding any server-only text, because since this is only going to be used inside of our server-only code here, it'll already be server-only. We're importing some prompt templates, start and end of variables from LangGraph, state graph, which is what we're going to use to create our LangGraph. Chat OpenAI, you can obviously replace this with any language model which supports tool calling from the LangChain library. Our GitHub tools, which we'll implement later, or after this, I guess. We're going to implement our base message, which we'll use for types, and then runnable config, which we will also use for types. Once we've added our imports, we're going to want to add our type for our LangGraph agent. So we're going to name it agent executor state. The first value is the input. This is going to be the input that the user submitted right here. Next is chat history. Once again, the chat history from their previous conversations. And then we have some optional values. These are optional because they're only going to be populated later on in our graph. So result, the plain text result of LLM if no tool is used, that's going to be this part. So if the LLM does not invoke a tool and only returns some text, that's going to populate this value. Next is the parse tool result that was called. If the LLM does call a tool, we're going to parse that and return it. That will be pointing to this conditional edge. And then finally, the result of a tool, that will be anything that this arbitrary function returns. And we're going to actually include the result of that because we want to update that in our chat history later on so the language model knows that it did, in fact, invoke and complete any tool request that the user asked for. After that, we can skip adding our nodes for now because we're going to want to construct the graph first. So we're going to create our agent executor function. This is going to create a new state graph, passing in our state, and then also creating these channels. Here we're going to add just two nodes, one for invoking the model and one for invoking the tools. Invoke model will obviously be this part. Make that a little bigger. And then invoke tools will be what happens when we pick a tool and we want to invoke that tool. Invoke model will then always call invoke tools or return, which is this conditional edge. This conditional edge will just check to see if the tool was used. If it is used, then this function will then return invoke tools. So invoke tools is called. If it's not used, then it's going to return end, which is this end variable. And that indicates to LangGraph that it should always finish. And that's what this is, where it finishes and sends the response back. Invoke tools will also then always end, so that once the tool is done invoking, it returns and finishes the LangGraph graph and responds back to the UI. And obviously, start is always going to call invoke model because that's the first thing we want to do in all of our graphs. We're then going to compile it and return our graph, and then we're going to use this a little bit later on when we're passing it to our stream runnable UI. And this graph right here will be the runnable that is invoked via stream events. So if we go back to our graph file, the first node we're going to want to implement is the invoke model, as that's going to be the first node which is always called. So if we paste that in, make this a little bit bigger, we can see it takes in two values. State, which is our agent executor state. This is kind of the magic behind LangGraph, where it'll always pass the state to every single node, even though we're not returning the full state here. So LangGraph can recognize what values in your state that you returned. It just appends that to the total state and then passes the complete state through to each node. So we take in our state and then also our config value. This is what we're going to pass to invoke so that our langsmith traces and the stream events all have the same, or all contain the same runs in the single trace, so stream events can get back all the values. First thing inside our functions, we define our prompt. You're a helpful assistant. You're given a list of tools. You need to determine which tool is best to handle the user's input or respond with plain text. We then have a message placeholder for the chat history. This is where our chat history will go, so the language model has access to all of our history. It's obviously going to be optional because there will be no history on the very first invocation. And then we have our human message with just a plain input argument. Next, we define our tools. We'll define those after this function, but we're going to provide three tools in the language model: GitHub tool, invoice tool, and weather tool. When we define these tools, we'll talk about what each of them do. Next, we're going to define our LLM. We're going to give it a temperature of 0, so it's more predictable and not as creative, I guess. We're going to use GPT-4o because that's their newest, fastest model, which can give us text back super quickly and also process our images. And then we're going to bind tools to this model, so all of the model has access to all of the tools we've defined. Next, we're going to use the LangChain expression language to pipe our prompt to our language model and create a chain. And then we're going to invoke our chain, passing in our input from the user's input and the chat history, and then also our config object. Once this is finished invoking, we're going to check to see if any tool calls were on the model, or if the model used any tool calls, and if they are, we're going to return this tool call value, which will populate this field. If the model did not use any tool calls, we're just going to return the content. Now that we've defined our first node, we're going to want to define our conditional edge, which will always be called after this node. Invoke tools or return. This takes in the state, and it essentially says if tool calls are defined, then you want to call the invoke tools node next. And if it's not defined, but the result field is defined, then we're going to end because that's just the string that was returned. And then this should never happen, but if for some reason neither of these are defined, then it's going to throw an error, but we're never going to get this, so that should not cause an issue for us. Finally, we're going to define our last node, invoke tools. This takes in the same input arguments as the invoke model, our state and our config, and it's going to first check to make sure there's a tool call. Once again, this should never happen because it should only call invoke tools if tool calls are defined, but because of TypeScript, we need to add this here, but we should never see this error. Next, we're going to define our tools map, which is going to be a map containing key value pairs. Each key is going to be the name of the tool, and then the value is going to be the actual tool. Using this map and our tool input, we're going to try and find the tool in there. Once again, this should never happen because our language model, especially if you're using a state-of-the-art language model, it should never pick a tool which doesn't exist, that you didn't provide to it. But we have this here once again for TypeScript. Once we have our selected tool, we're going to then invoke that tool, passing in the parameters that the tool called for and that the language model provided to us in our config. And then finally, once we get a result back, this result will always be a string, but usually we're returning an object, so we're going to parse that result and then return it in our tool result value, which will populate this field. Now that we've done this, we've implemented our entire agent, and we can go and implement our tools, which we will then provide to the agent. These tools are going to contain all the logic around streaming back UI components and hitting any external APIs. So for our tools, we have this tools folder, which contains some files, GitHub repo, weather, and invoice. We're just going to implement the GitHub repo tool, and then I'll quickly walk through the other tools because they're all pretty redundant and contain kind of the same logic. But for our GitHub repo tool, we're going to want to add our imports first. We're going to be using Zod. Zod is what we're going to use to define the schema, so the language model knows what parameters to pass or extract from the input and then pass to our tool. Octokit, which is the GitHub API wrapper SDK, which is what we're going to use to actually call the GitHub API. Create runnable UI, which we defined in our server.tsx file, which is going to wrap that lambda, create a new streamable UI, and that's what we're going to use to actually stream back these UI components. Our tool from LangChain, and then our pre-built components, which we can quickly look at. We have a loading component, which just contains some skeletons to show that we're loading, and then the actual component, which contains a card. This card is going to have a link to the GitHub repo. It's going to show how many stars they have, the repo description, and other things like that, which we'll get back from the GitHub API. The first thing we're going to want to do is define our schema. Our schema is going to be the owner and the repo, which are the fields that the GitHub API requires in order to fetch details about a repository. If the language model sees that a user has submitted an input with an owner and repo fields that look like a GitHub repo, it'll likely call this tool and provide us the name of the repository and the repository owner. Next, we're going to define our function, which will actually call the GitHub API. We're going to call it the GitHub repo tool. The input is going to be the type of our Zod schema, so z.infer type of our schema, and that will infer the type here. Next, we're going to make sure you have your GitHub API token in your environment. If it's not, we're going to throw an error. Obviously, if you're going to use this tool, you should set that. In the README of this repo, I add instructions on how to get all of the API keys you need for free for the different tools, except for your language model API key, which will obviously cost money when you invoke the language model. We're then going to instantiate our Octokit SDK, passing in our GitHub token, and that's going to return an instance of the GitHub client. Then we can just call our GitHub client, calling the repos with a GET request, and that's going to get us the information on this repo. And then we return the data from the API response, which is the input. So we have the owner and the repo, and then the GitHub repo description, how many stars they have, and the primary programming language. If there's an error, we're just going to return a string, and then we'll process this inside of our tool to return either the GitHub final component or an error component if an error was occurred. Now we can implement our tool. It's going to be a dynamic structured tool with a name, GitHub repo, a description, a tool to fetch details of a GitHub repository. We're going to pass in our schema, so the language model knows what fields to provide. And then we have our function. Inside this function, we see it takes two arguments, input, which should be the schema we defined, and then config. We're going to first create a new runnable UI stream, passing in our initial value, which is going to be this loading component, and this is going to tell the user that as soon as the language model picks this tool and this function is invoked, the user is instantly going to get back their first loading component, so they see that we're working on something. That's this step here. Next, we're going to hit our GitHub API with this function we defined above, passing in our input. Then if the GitHub API returned a string, there's an error, and we're just going to return a p tag with the error message, calling stream.done. If the type was not a string, so this object here, then we're going to return our GitHub component, which is that JSX component, which will actually show all the data, passing our data, and finally we're going to return the result of our tool. You can also call stream.update or append as many times as you would like. If you want to say, hit an API, update your tool, hit another API, add some more values to that UI element, you can really call update and append as many times as you would like to keep interacting or updating that interactable UI component with the user. The nice thing about this as well is since it takes in a React node, our GitHub component these don't have state, however, they could be stateful. They could contain some button which hits an API or makes another language model call, which then updates the UI again. And they're really just generic React components. So everything that you could do before with React components and make them super dynamic and interactable, you can do that here as well, because it's any sort of React component you want, and you can pass props to it. So they can take in these different inputs and be dynamic and customizable for the user. So now that we've implemented these tools, we can quickly look at our invoice and weather tool. Invoice is just a schema. This is because we're going to want the language model to extract these fields from any uploaded image. And then it just creates a runnable UI with this initial loading, which is kind of redundant because then it instantly turns around and updates it with the final component, but just to show the same thing, and then it returns the input. And then for the weather component, or for the weather tool, same thing. Our weather schema is a city and state, and then an optional country, which it defaults to USA. And then it hits a couple APIs. If you want this API key, I've added some instructions in the README on how to get it. It's totally free. It's going to get the longitude and latitude from this API, and then it's going to use the weather.gov API, which is free, passing in these values, and then it's going to extract the current weather for your location. The tool, also the same thing, creates a stream, passes back that loading weather component, then it invokes our weather data function to actually get the weather data from these APIs, and finally it updates the weather component with our with the data that the API returned. Finally, we're going to want to implement our chat JSX component, which is going to be the chat you can interact with. If you want to follow along, you should go to component/prebuilt/chat. This can be a client component because it is not actually using anything in the server. Instead, it's going to call our server component. We're going to have a state, input, which are just some shad CN components that they built. Endpoints context, which we already defined here. Or sorry, we need to define this after this. Our use actions, which we saw how was defined, that's going to provide the agent action for us. And then our context, which is going to provide context to our action and also render our UI elements. These are just some util functions on converting files to base64. We need to convert them to a base64 string on the client because React Server components don't allow for any arbitrary function to be passed over the, any arbitrary object to be passed over the wire. Only specific objects and obviously key value pairs where they're both strings. And we would need to convert it to base64 on the server anyway, so we just do it on the client because they don't allow for file objects to get passed over the wire. So it's now a string, and we send it over, and then we use it to invoke our language model. For our chat function, we're going to want to add our state variables first. Our use actions hook, providing our endpoint context, which is our agent, takes in our inputs, which we also see here. This is how we're going to then invoke our agent. We then have a few state variables. Elements, which is a list of JSX elements. These are going to be the elements that the UI returns to be rendered. Your chat history, input, and then any selected file you've selected. Here we see we're wrapping our elements with this local context.provider context JSX element, and that's going to provide context to our React elements. And then we have a simple form, as we would see right here, just for submitting your inputs and any images you might upload. Next, we're going to want to implement our onSubmit function, which is going to actually call our agent. So this onSubmit function does a few things. We're going to paste it in and then walk through it. So first, it makes a copy of our elements array. So in case this somehow gets updated later on, it's not going to mix and match them. So it's always going to be the same at the beginning of the function. It's then going to convert your file to base64 string format if you did upload one. And then it's going to use our agent action to invoke our agent. This is going to return an element, which is UI and last event. We saw that here. It's essentially calling this function, which returns our UI and last event, passes any necessary inputs, and then updates our element array with the UI value from our return value from our agent, and then also the human message that the user submitted, and then if they uploaded a file, the file. Finally, we saw in our server function, the first function we implemented was this with resolvers. We're going to use that here. So element.lastEvent, which once again is the last event here from our with resolvers function. It's then going to check and see if it's an object. This right here is specific to this chatbot we've implemented. So you're obviously going to want to update these to reflect your LangGraph node, or nodes. We have invoke model and invoke tools, as we defined in our graph. So if it's an object, then we're going to want to see if last event.invoke model.result is true. That would be this plain text string. If it is, then we update the history with that plain text. And if it's not true, that means that tool was used. So we see invoke tools, and then we update our history, but make the assistant message be this tool result and then the result of our tools. And that's so the assistant knows it successfully completed the request we made in the past using the result of our tool API. And that's so you can say something like, what's the details on this GitHub repo? It sends the response. It didn't actually give you any text, so there wouldn't be any text in the chat history. But since we are creating this assistant message, when you send a follow-up, it's able to see your question and see that it was submitted or resolved, and it knows it should ignore any questions in your chat history because it's already resolved them here. Finally, we clean up by setting our elements state value and then clearing any inputs. Finally, we can go and implement our agent wrapper, which is going to use this stream runnable UI function and call our graph agent executor function. And that's what we're going to use to invoke our agents. Let's go implement that now. So if you're following along, you should go to app/agent, and you're going to want to paste in our imports. Once again, server only, because we're going from this client component to our server. So we want to make sure it's only invoked on the server. We're then going to import our agent executor from our graph, which we built a little while ago, and our expose endpoints and stream runnable UI from our server file, which we invoked in the first part. Finally, we're going to want to import our AI message and human message, LangChain message types. We're going to use this when we're constructing our chat history to give the proper message types to our chat history. And this will also, when we look at the LangGraph trace, you'll be able to see human message, AI message, human message, AI message in the proper types. So the language model knows what or who said what. Now we can implement this little util function for converting our chat history type, see from chat, role, and content into a proper list of human message and AI message. So iterate over. If it was a human, then return a human message, or assistant or AI, return an AI message. And then by default, we're returning a human message. This could also be, say, chat message from LangChain core, and this would just be a generic. We also need a role, so you could say, role. And this would just be a generic chat message, and it wouldn't be specifically human or AI. But in our case, this will probably never happen because we know we're always adding this role and assistant, but we're adding it just to make our switch case happy. Next, since we're doing image inputs, we need this process file function. This is essentially going to process any files you upload and convert them to the proper message type for passing multimodal inputs to our language model. So if file is defined, it's going to create a new human message, passing in a content, which is a list of type image URL, and then image URL with our base64 conversion of our file. And this is the proper template format for uploading multimodal types to language models. I'll added a link in the description to our multimodal how-to guide in the JS documentation if you're interested in that. And then finally, we return our input and our chat history, which matches, as we saw, the input and chat history from our LangGraph agent. If you didn't upload a file, then we just need input and chat history and don't need to do anything with image prompt templates. Now, we need to implement our agent function. This is going to be the function that when you call, actions.agent, this is going to be the function that it's going to invoke. So it's going to take in, as we see, the same inputs we were passing in here: input, chat history, and file. Use server, so we make sure that this is always executed on the server, as in a React server component. We're then going to, this does not need to be async. We're then going to process the file to get the process inputs, which is input and chat history. That's going to do what we saw up here. And then finally, it's going to return a new stream runnable UI, passing in our agent executor, which is our LangGraph agent, and any inputs. We saw this already, but this is just going to call stream events on our runnable, which we pass into it, which is our agent executor function. And the last thing we need to do is actually create, expose the context for this agent so that our actions.agent and with our use actions hook has the proper context available to invoke this. So as we see here, there's an error because exposed context does not exist yet. But once we expose our context, passing in our agent function and export this, the error goes away. And as we see with our actions.agent, it has access to our agent function with the same inputs we just defined. Here we see we're passing expose endpoints, this agent function with the same inputs. And this just gives the proper context to our client component so it knows that it can invoke this agent. Now that we've implemented all of this, we can go and actually demo our application. Restart. Go. Now that we've implemented all of this, we can go and start our dev server and actually check out our demo. So we're going to want to navigate to your terminal, go into the proper directory and run yarn dev, or you can build it and run yarn start, kind of the same. Once it's running, we're going to go to localhost 3000 and we will see our website. So Generative UI with LangChain, we see our chatbot and our inputs. We can say something like, what's the weather in SF? It then streamed back our text. If we go back here, we can see that the language model decided it did not have enough inputs from the user to select the weather tool or any of the other tools, so it just sent back some text. But since we've implemented chat history, it said, can you please specify the state? So we can just say California, and it's going to use our chat history and our current message to then invoke the weather tool. And we see right there, there's a loading component because it picked the weather tool, sent us back our loading component, and then went and actually hit the weather APIs and then updated this component to show the actual weather. We can also say something like, what's the deal with my invoice? And we can upload an image. Let's say we upload our receipt. We submit that, and this is going to use GPT-4o's multimodal capability to read our image and then send us back this nice, fully interactable, if you implemented this component and it wasn't just a demo, receipt component or invoice component. And this is all populated with the receipt image I uploaded, so it extracted the fields and then passed in the proper properties to this component so it could render. And then finally, we can check out our GitHub component, which we implemented. So what's the info on LangChain AI / LangGraph? And our language model is going to be able to recognize that this is a GitHub repo. So we submit that, and then error doing that. So I wonder if I spelled something wrong. Yes, I spelled LangGraph wrong. Try LangChain AI / LangGraph. Because we saw there, it gave us our loading component, but then the GitHub API returned an error, so it just responded with this string. When I did it properly, it gave us the proper component, and then obviously it's fully interactable, so you can click on this, and it'll bring you to the LangGraph repository. That's it for this video. If you're interested in the Python video, it's going to come out tomorrow, or if it's already released, then we will link it in the description, where we will implement this exact same chatbot demo website, but with a full Python backend. I will see y'all in the next video.